graphing lines is one small thing added. So we're dealing with inequalities now. So inequalities is a range of answers in an equation. X is equal to 2. In an inequality, X is greater than or equal to 2, or less than or equal to 2, right? So there's a range. So inequalities is not one specific value. So you guys know what your inequalities are, right? You're greater than, less than, greater than or equal to, less than or equal to. There's 4 of them, right? You got this one. You got this one with the equal to sign. You got that one. You got that one with equal sign, right? You guys did these in grade 9 on a number line. You guys remember that? Maybe vaguely, way back. So we're going to take, actually that's tomorrow's lesson. Today we're going back to grade 10, and then tomorrow we're going back to grade 9. So it'll be lovely. It's a trip back in time. So when we do, and so this one's a little bit heavy on the graphing. 2 out of the 3 lessons are all graphing, but they're not bad. They're not like chapter 7 graphing bad. Like these are okay. I promise you'll be fine. So when we graph them, we've got 2 parts to it. The boundary, which is like the equation to the line, and then you've got the shaded region, or the region of possible correct values. So the boundary is like your line, like your actual equation, and the region is the area that we shade. Okay, so boundary and region inequalities in both. When you have an equal to sign, it's just a boundary, it's just a line. Okay, you're going to have to make decisions about what kind of boundary you're going to use. If it has the equal to sign, you're going to use a solid line. If it doesn't, and that means any point on that boundary is correct. If it doesn't have the equal to sign, that means the boundary is literally what it's like an asymptote. Like it includes everything up to it, but it does not include that line. So like an asymptote, we're going to draw that with a dash line. Okay, so values on the boundary are not included in the solution. You guys good with that? Okay. Start. Okay. Ooh, that's some serious lines. I got this blind thing going here. Okay. Graph this. Okay, so some of you may not feel comfortable with it in this isn't even standard form or general form. It's either of those. You might not feel comfortable with this. Most of us are comfortable graphing lines and y equals, right? Like that's normally where we're comfortable with. So we can do one of 2 things. We can graph this with a table of values, or we can rearrange it so that it's y equals and you feel more comfortable. Rearrange it. Okay. Okay. All right. So if I'm going to rearrange it, I've got 2y is greater than or equal to 10 minus 4x. Okay, so you guys remember the secret rule? There's lots of secret and invisible things in that. The secret rule when we're dividing using inequalities. You guys remember that? If you divide by a negative, it switches. If you divide by a positive, it stays. So if you don't know that, or you need to remember that, that would be something I've written down. I don't think it's 2, I'm not sure. So I'm going to divide by a positive 2. So if I'm dividing by a positive 2, my sign does not change. Okay, still not the right form. Do we all feel better about graphing that line? Yes. Okay, welcome back to grade 10. So for those of us who aren't as comfortable graphing lines, we left that back in grade 10. This is my y-intercept. And this is my slope, which is rise over run, or or the change in y over the change in x. All of those things should be popping off the page to you. If you need a refresher, I'll be starting that tomorrow with my grade 10. It will be painful. So the way I do this is I'm going to put on my y-intercept first. That's the very first point I graph. I should probably put some increments on here. Okay, so that's the first point. My y-intercept is at +5. And my slope tells me rise over run, so y over x. So it's in -2, so I'm going down to 1 to the right. So I'm just going to use slope. So down to 1 to the right, down to 1 to the right. I think that's right. This is exciting. I could also go up to, but then I would go one to the left. This coming back to you guys? Sort of, maybe? And then we connect all these points. Oh, imagine that's a line that goes through all those points. Okay. So you guys comfortable now? Oh, silly me. This is my boundary line. So what I just drew right here is my boundary line. But I didn't take a minute to decide if it was solid or dashed. It's solid. So it works out okay. But I didn't stop and think about it, and I probably should have before I connected those dots. So it's going to be a solid line because it has the equal to sign. Is everybody good? Yes? Welcome to grade 10. Okay, and what I mean by a table of values will never lead you wrong. If you don't remember how to do this, you could have gone from here and picked your x's and y's. You could have done a table of values. If you didn't want to rearrange because you don't remember the rule, like am I supposed to flip it if it's positive or negative or whatever, I don't have time for that in my life. I'm just going to use a table of values. For me, this is plan A. For me, this is plan B. It might be opposite for you. That's okay. So if I pick -2, substitute -2 here, I'm going to solve for y. So that would be -8. Bring that over, that would be 18. 18 divided by 2 is hopefully 9. So this would be 9. And if I look here, -2, that's at 9. Right? So this table will match exactly what I did here with the pattern. So tables of values will never lead you wrong as long as you don't get lost in the substitution. If I put 1 in here, -4, then it's 14. So this would be 7. Oh, look, this is at 7. At 0, it should be 5. If I put a positive 1 in here, that would be 6. So this would be 3. Anybody notice anything in my table? What are my y's going down by? What was my slope? -2, right? So those are the connections that we made way back in grade 10. I think sometimes though, when you hear it the first time and see it the first time, you don't always absorb it the first time. Now you're looking at it going, oh, that makes total sense. Perfect. I wish I knew that in grade 10 when I was taking tests. So if this makes no sense to you or you don't remember how to do this, a table of values will never lead you wrong. Especially with linear, because it doesn't matter which one you pick. Okay, so I have that. So that was grade 10. The grade 11 part of this is it's an inequality. So we've done the boundary, and we said it was a solid line. And now we're going to figure out what region, what part of the graph. So it's either going to be on the left side or it's going to be on the right side. That's included in the solution. So all I'm going to do is I'm going to pick, so for my shaded region, I'm going to pick a test point. Okay. You're going to pick an easy one. So which one do you think I'm going to pick? And if I'm going to pick an easy one. How about 0 and 0? Okay, so you can't pick a point on the boundary. You have to pick a point in the region. So you can't pick a point on the sign because we know that that works. That's going to be true. We just grabbed that. So you got to pick a point that's like to the left of the line or to the right of the line. And you crazy people, I'm going to pick 0, 0. Oh, really? Oh, well, let's just do it my way. Okay, I'm going to pick a test point 0, 0, and we will answer that question that I asked. So I'm going to pick the test point. I'm going to substitute it into the original, which was 4x plus 2y is greater than or equal to 10. Is that the equation? I can't see it, but yeah. Okay, good. So this is going to be 0 is greater than 10. Is that a true statement? No, that is false. So here's the deal. 0, 0 is right here. And if that is false, we shade only where it's true. So if it's false on the left-hand side, it must be true on the right-hand side. So we would shade. I'm going to go for the crayon. Just the regular crayon. Oh, I regret my leg choice. I regret my leg choice. Absolutely, you can. I don't have any crayons. I have color pencils behind cam. You want to get crazy. Okay, so the question asked me is 1, 3 or part of the solution. So I'm going to go back to this. Over 1, up 3. That's actually on the line. But it's a solid line, so it is equal to. So the answer to this question is yes. At any point, who picks a black crayon? Like, that's the least exciting crayon to shade this. I should have orange and think it would have been beautiful. I've got a Halloween theme going on here. So anything in the shaded region means that it's true. So just to prove my point, because I know you guys are super excited to prove my point. If I pick a point in this shaded region, so I'm going to pick 3, 3. Do you guys agree that 3, 3 should be in my shaded region? Sure, I love that. That's my favorite answer. Yeah, for sure. 1, 3 is actually on the line. It still counts because there's an equal sign on your inequality. If your boundary is solid, all the points on that line are good. If it's a dashed line like an asymptote, then it would be false because it includes everything up to, but not including that. Okay. So this would be 4 times 3 plus 2 times 3 is greater than or equal to 10. So 12 and 6 is 18. 18 is greater than or equal to 10. Is that a true statement? Yes. So our goal is to pick that test point and only shade where it's true. It's either going to be true or false. There's no other options. So because I picked 0, 0 and got a false, I'm not going to do the math and pick another test point on the other side to confirm that it's true. You can just, I don't want to say these words out loud, but you can just assume that it's true on the other side. That doesn't feel right to me because the math should never assume things. But if it's false over here, yeah, but like the math person inside of the math teacher is like, oh, maybe I should test it just to make sure everything went off all correct, right? Like that's me inside. So if you are like me and you just want to double check that it's right, just pick a point on the other side of the line and double check that it's correct. Okay, so that's my Halloween dress. Everybody comfortable with this? This is nice. Like it's like, hey, this is great. I'll just go through all the holidays in my lesson. All right. We're gonna graph this one. What do you want to do? Yep. No, this unit is like smiling all the way through.
You told us that
This one I'm really serious. This one's like easy sailing. And fair enough. And 8 also easy sailing. We're finishing with the easier units. Yeah. So we can all like read the side of these, get 100% on our quizzes and tests and like that. And then try about the exam. Do we want to rearrange again? Yes? Okay. Okay, so now, thanks. Couple of things, dash y right away. We know it's a dash y. We're also dividing by a negative coefficient. So this side would be y is less than 2x. Yeah.
Why just move the negative 5y to the first element?
Absolutely. Absolutely, 100% of that. The small pointy part is still going to be pointing at the y. Yeah. So either way you do it, just if I'm rearranging to make us feel comfortable, oftentimes putting a y on the right side doesn't make us feel comfortable. I can do it anyway. Like I can move things around, I can do a table of values, I can change nothing and still be okay with this. But we said we're more comfortable with rearranging, and my guess is we're probably more comfortable, and it's funny, because in math it really doesn't matter, but we always put that single variable on the left-hand side. We are conditioned. Society has conditioned us to have our dependent variable on the left-hand side. Who knew? We're conforming to society's norms. Where? Right, that's okay. Where's my y-intercept on this one? 0. It's not stated, but it's there. I don't need to put that, but as long as you know it's there, I'm just trying to go back to grade 10 and practicing for teaching my kids tomorrow. So you guys are making me pace. And my slope is 2, which is 2 over 1. Yeah, I'm going to teach a lesson. Okay, for the record, they're crazy. I think you guys are more than welcome. I would love that. These guys are intense. They are awesome people, but together as a group, like it's frightening. Like yeah, the one after this one. Yeah, exactly. They're nuts. Yeah, but I love them. I love them. They're great people, but just like collectively, woo, they're intense. Okay, so these guys, so my slope is 2 over 1. So that means now it's positive 2, so I'm going up 2, 1 to the right, up 2, 1 to the right. What? You don't? Okay, you're in. Okay. Do you want to teach them on Friday? It's slope. So you're teaching them what you're going to teach them. You're going to teach them slope, part 1 and part 2. All right. Today we're doing a test. Teach them how to do slope. I have the notes, everything's ready to go. You just got to come in and. Okay, so remind us that there's no equal sign. So what does my boundary look like? Dash line. So what I usually do is I forget to check, and then I just go back with my eraser, and I just take off little ticks. That's what I usually do. All right, so we've done our boundary, and we've done it correctly because it's a dash. It's a dash line. Now we're going to do our test point. I can't pick 0, 0. Because it's on the boundary. 1 and 1. I can do 1 and 1. I always like to put students to my original, not my rearranged. One. Where is it? Great, that's my. So 1 1 not on the line, it's on the right hand side. Pick one that's not on the line. I pick nice numbers. Let's pick nice numbers that are going to make you cry. Yeah, like don't. Yeah, like don't do stuff. Well, I mean, go ahead if you want. 5 is greater than 0. Is that true or false? That's true. So that means we are shading on the right-hand side of the line. Or some people say below the line or above the line. I don't know, whatever makes the most sense. Don't cross the line. Yeah. Have you met me? Like, have you seen my drawing and my ability to shade things? Like, I'm not one to judge. I think if it's like I want it significantly shaded to indicate what side of the line is the solution region. Okay, I'm both agreeing this time. We're doing all the holidays. I got the orange and black starting the theme. Hey, it's a Christmas tree laying on its stuff. So are we going this way?
Yeah. So that would be like
I'm not with you. We have to do cosine on sine. I tried. Put some decorations on it. Yeah. Okay. If you put a test point on the graph, if you put a bunch of test points, okay, let's go back to the actual map. I know we want to decorate our tree, but if we put a test point on the graph, like I put it on there to show you where it was for 1 1 1, and let's say we put it on the side that was false, you would have to remove it. Does that make sense to everybody? Because you can't have a point out here, because now you're saying everything is included on that point, which would be incorrect. No, we just happen to pick a test point inside the region, so it's okay that I leave it. But if I had picked a test point at -1 and 1, I would have to erase it because it's not included in the solution.
How about not drawing the line?
For sure, and I don't even put the point on it. I didn't even put the point on it. But if you did do that, like just to remind yourself where you're shading or not shading, if it turns out to be false, you do have to remove that point. Right. No, you shade on the other side of the line. So if I picked a test point over here, it would come out false in the equation, right? And so that's supposed to be, don't shade on this side, shade on the other side. No. Nothing can be marked on the non-solution side. Okay? This has to be clean over here. You have to remove it. Like if you drew your test, like you can pick a point over here. You can pick a point. We did that on the first one. And notice I didn't label 0, 0. I didn't draw that in because we all knew where 0, 0 was, but some people were asking me where, are you sure 1, 1 is on that side? Okay. Never pick a point on the line. But that was a question given. That wasn't the point that I picked to be a test point. Oh, okay. So That was the question given.
We didn't plug that anybody.
Well, I looked at my graph and 1, 3 is on 1. That's what I did. Okay. Everybody okay with that? Decorate your tree accordingly. All right, so now we're doing it backwards. Sorry, you guys have the shading and I don't. So here shaded, below is shaded on the next one. And then above. And above. Is it? Yeah, I'm sorry. Do you want me to undo it? Okay. Okay. Okay, so now this question says I want you to create an inequality. So right away, boundary and shaded region have to be included. If you see a shaded region on the graph, you know it's an inequality right away. So you're going to create the inequality that goes with each one. Okay, so this goes back to grade 10, you're creating your equation. So for graph 1, I have a y, I have some inequality, I'm going to have an x, and I'm going to have a y-intercept. So what's my y-intercept on graph 1? So it's going to be minus 4 up here. You guys agree with me? Now we're going to calculate my slope. So I go up 4, over 4, and I'm rising to the right, so I know I'm going to have a positive slope. So that's going to be 1. So now I just got to figure out my inequality. And I figured out the grade 10 pieces to the equation or to the inequality. Now I got to pick a grade 11 piece. Now it's shaded here. It's shaded here. Everybody with me so far here? So this we know has to be a true statement in the shaded region. So I'm going to pick a point in the shaded region. I'm going to pick 2 and negative 4. You're not invited to the party anymore. So I'm going to substitute those values in. So negative 4, and we have 2 minus 4. So negative 4 and negative 2. Create an inequality that will make them true statement. Okay. Do you guys agree with that?
Yeah.
Right? Because it's the alligator is going to eat the smaller number, bigger number, sorry. And is that a dash line? So this is my inequality. Does that make sense to everybody? Okay. So graph 2. Pardon? I put it because I'm trying to figure out what that inequality was going to be.
Oh, so.
The little cloud, yeah, I forgot my little cloud. Yeah, because I needed to do, it's like the ambiguous cases. You need to kind of figure out what side is greater than, bigger than, less than, that sort of thing. Also on graph 2, what are the parts of my equation? I've got a y, I've got a fluffy cloud. Is my slope still 1? Because it's still rising to the right, so I know it's a positive slope. Over 4, up 4, so that's just 1. And I cross at a positive 4 this positive 4 this time. So now we have to figure out which way my inequality goes. So again, you pick a point in the shaded region, and you're all going to pick 0, 0, right? Perfect. So fluffy cloud. And so what statement, which way is the inequality going to go? So 0 and 4. So 0 is less than 4. So my inequality would be y is less than x plus 4. The trick with these is you don't get to pick on which side. You must pick in the shaded region. Because it's telling you this is the solution. The solution is here. So you're looking for making an inequality order. Was that an equal to or a straight one? Just a straight inequality. It's dashed, so no equal sign, right? Okay, graph 3. Graph 3. So y, fluffy cloud. Slope still 1. Still a positive 1. This is nice. X plus 4. And now we're shaded above the line. So we're going to pick a test point, let's say -4 and +4. Why? 4 fluffy cloud, -4 plus 4. So 4 and 0. So 4 is greater than 0. So that would be my inequality. Okay, you guys do the last one. Did you all get that? Yes. Did you get the equal to sign? Yes. Because it was a solo. See, don't you feel good about this? Like, chapter 9 is like, and then there's the word problem. But it's not terrible. Okay, so this goes back to grade 9, 10, one of those years. Okay, so you are creating this beautiful artistic mosaic to represent your love of math. You can make it out of tile and stone, and you only get $150. Okay, you can spend less than $150, but you definitely can't spend more than $150. You can spend $150 on the nose, but you cannot spend more than that. Everybody with me? Yes. Easy peasy. So we're going to create a linear equation. So, I got tile. I'm going to say, let t equal number of tiles. And then I'm going to say, let s equal I guess it should be square foot of tiles. And this one should be because it's not number. We're not buying them by stone. We're buying them by weight. Does that make sense to everybody? Like, so square foot of tiles, it's not paying per tile. And it really in the story usually pay per tile. Or like sheet of tile. Things that you will never know until you decide that you want to renovate a kitchen or a bathroom, and then also become really important. Okay, so we're going to make a statement. What is the amount of money I've given you for the project? 150. This is the stuff you're going to buy. Okay? So what do we know? If this were an equation, this side, left side, right side. What do I know?
150 is greater than 40. And you don't even need 150.
Okay, all right. I'll give you. Okay. So this side has to be less than or equal to 150. You guys know this because I give you 3 $50 bills, and that's all you got. So you know you can't go over. So this side has to be less than or equal to 150. Make sense? It seems really really easy when we say it in words, but then when you look at it, I'm not sure sometimes the reading comes out. So we know that the cost of tile is $2.50 per square foot of tile. And we are going to add some stone to that, which is really expensive, 6x. So we know our stone, however many kilograms we have, equal to, or plus our tile, however many square feet of that, has to be less than 150, or equal to. Okay, so create an inequality, done. To represent the situation and then solve the problem. And the only way I can really solve this is because there's many combinations. You could sit here all day and give me an infinite number of combinations. But you're not going to do that because you don't have that sort of time. Okay, you were going to do a graph to show the solution. Here's something so better. I have no affection to whether tile is on the Y or S is on the Y. It doesn't matter to me. I just randomly picked that. Everybody with me so far? Now, the easiest way to do this, have you guys heard of intercept method? Your poor grade 10 teacher somewhere is crying. And I know it wasn't me because I didn't teach it last year. So intercept method is find your x-intercept, find your y-intercept. So my y-intercept in this case is my t-intercept. So what do we know about s when I'm trying to find the t-intercept? S is 0. Okay. So to find the t-intercept, exactly. You buy no stones and you do the whole thing in tile. That doesn't sound very mosaic to me, but we will forgive. So that means I have 150 less than or equal to 250t plus 6 times 0. Ooh, forgot my t. T is in plus signs. 60? You don't even need them up. I love it. 60. Okay, so we know that if we only use tile, we would need, is that money or square feet of tile? That's square feet because tile is measured in square feet. So this point would be 0 and 60. Okay, so we've graphed the t-intercept. Now we're going to graph the s-intercept. And what do we know? What do we know about t at this point? Only stones this time. I'm going to lose my mind. Oh, my t has an equal sign in it. So this one's going to be 150 is greater than or equal to 250 times 0 plus 6s. What do we get? 25. 25? Let's say 25 meters. So this is going to be at 25 and 0. Okay, you guys with me so far here? Yes? All right. I know my boundary is solid because it can equal $100. So any combination on this line will give me exactly $150. But we know we can spend a little less than $150. So what's an easy test point for this? 0, 0. I buy no stone and I buy no tile. What do you think that is? It does not create a mosaic. You failed at the art project and you don't love math and all of that stuff. So what this is saying, so 0, 0 would be true. It would be 150 is greater than or equal to 0, which is a true statement. So that means we are shading this part of the line. Now, I will be particular about this. When you made this a 4-quadrant and you shaded here. Now, why would I be upset about that?
And I mean, there's.
You have a negative stone and you have a negative tile. So, I mean, like, on you, the story, I don't know how this works.
What's the big and nine, right? Have to be the line segment in order to bound line.
Right, because of the context of this situation. So these should not have arrows on them. They should have circles, closed in circles. Very excited. Yes, math, yay, math. So this should not have arrows on it, and this should not continue into the negative quadrants. But it's because of the context of the situation. These graphs didn't have context. They just gave you the equation. They didn't say what it was about.